So notice that I've been using indefinite integrals so far, and that's because with definite integrals, I have to be mindful of the fact that my bounds in the original definite integral are in terms of x. And remember, to be a good substitution, all of the x's have to be gone. It can only be u's. And that means my bounds have to be u's as well. Uh, so this is also a really good place where using arrows instead of equal signs to connect your steps is a big, big help. So if I have the integral from 2 to 5 of 1 over 2x minus 3 with respect to x, first thing in my mind is, do I know if that of any function has that as its derivative? And off the top of my head, no. So I think chain rule. So I want u to equal an inside. Well, the denominator is a good place, is a good place to start. So I'm going to try u equal to 2x minus 3, which means du dx is equal to 2, and dx equals 1/2 du. So I've got the integral of 1 over u times 1/2 du. But I need to change my bounds, because 2, if I put 2 as my lower bound, that's an x that's 2. And I can't have any x's for this to be a good substitution. I need to change that 2, that x equals 2, because this is an x, and this is an x. I need to change them to be u's. Well, if x is 2, u would be 2 times 2, which is 4, minus 3, which is 1. And if x is 5, u would equal 2 times 5, which is 10, minus 3, which is 7. So my lower bound is 1, my upper bound is 7. Advantage to this, I'm not going to have to go back to x's because my bounds are already u's. So I have 1/2. Antiderivative of 1 over u is the natural log of the absolute value of u from 1 to 7. Because my bounds are already positive, I really don't need the absolute value. So I have 1/2 times the natural log of 7 minus 1/2 times the natural log of 1. And there is my evaluated definite integral. If you have problems with the bounds and you do want to go to x's, what you would do, and I do not recommend this, but it is another way of doing it. If you do it this second way, you must be using arrows and not equal signs. And you still have to know how to change the bounds into u's for the AP exam. But an alternative would be that I'd have the integral from 1 over u times 1/2 du, and I would ignore the bounds and I would treat it like an indefinite integral until I'm back into x's. So 1/2 times the natural log of the absolute value of u, 1/2 times the natural log of the absolute value of 2x minus 3. And now my bounds would be from 2 to 5 because I'm back to x's. But if I do that, it leads me back up here. I do not recommend the green method because, one, AP exam will ask multiple choice questions to see, do you know how to change the bounds into u's? And two, it introduces too many places for a mistake. It's just easier to do it the red way, where you change the bounds into u's when you change everything else into u's. So a second example of this is integral from 0 to 4, tangent of x, secant squared of x dx. I'm going to say u is equal to tangent because I know the derivative of tangent is the secant squared. So from experience, I know that I can cancel out the secant squareds when I substitute for the dx. So I'm going to have the integral, tangent is replaced with u, times secant squared, times 1 over secant squared, du. If x is equal to 0, u is the tangent of 0, which is 0. If x is pi over 4, then u is the tangent of pi over 4, which is 1, so it's 0 to 1. So I have the integral from 0 to 1 of u du, which is 1/2 u squared from 0 to 1, which is 1/2 minus 0. And there is my evaluated definite integral.